explicitly close the file when we're done using it. And to do this, I'm going to do it by saying f.close. So now that we've closed that file, let's go ahead and run this, and you can see that it printed out the name of the file that we opened. And so this has some more information that we can print out also. If we wanted to print the mode that the file is currently opened with, I can do a f.mode, the mode opened. And so this has some more information that we can print out also. If we wanted to print the mode that the file is currently opened with, I can do a f.mode. And if I run that, you can see it prints out a lowercase r because we opened the file for reading. Okay, so now even though that this works the way that we've just now done this, let me show you how to instead open the file using a context manager and why for most use cases you'll want to work with files this way. So if we open the file like we did here, then we have to remember to explicitly close the file. If we don't close the file, then you can end up with leaks that cause you to run over the maximum allowed file descriptors on your system, and your applications could throw an error. So it's always important to make sure that you close the files that you open. So in order to use a context manager, then it's kind of similar, but we can do this using the with keyword. So we can say with, and then I'm just going to copy all of this. So with open test.txt in read mode, and then here at the end I'm going to say as f, and then I'm going to put in a opening for our block here. Now this can be a little confusing to people at first because the variable name is actually over here on the right using as f instead of over on the left when we said f equals open. But the benefit of these context managers is that they allow us to work with files from within this block, and after we exit that block of code, it'll automatically close the file for us, so we don't have to worry about whether or not we add in these closes here. Now this will also close the file if there are any exceptions that are thrown or anything like that, so that's why using these context managers are considered a best practice, and it just automatically takes care of all that cleanup for us. So now I'm going to go ahead and delete my outside open and close statements there. Now, one thing that some people don't realize is that you actually have access to this f variable. For now, I'm just going to say pass within this context manager. Now, we actually have access to this file object variable after we exit the context manager, but the file will just be closed. So for example, if I print the closed method on f now and run that, you can see that it returns true. But even though that we have access to this variable here, it is closed, so it's not like we can read from it. Like if I try to read the contents from the file and print that out, then you can see that it throws a value error here, and it says IO operation on a closed file. So for what we want, we're going to have to work with this file from within this context manager.
Siri's dictation was driving me crazy, so I switched to WhisperFlow. Here's why I'll never go back.
And for the rest of the video, I'll be using these context managers to work with files since it's a good practice, but I wanted to show you the other way first in case you see it in examples or wondered why I wasn't doing it that way. Okay, so back to our file. So we just tried to read the contents from the closed file and got our error, but let's look at how we can read the contents from the file from here within our context manager. So let's create a variable called f_contents, and this will just hold the contents of our file. Now, if we do an f.read, and if I print this out, oh, and actually I need to print out that f_contents. So if I save that and print that out, then you can see that it printed out all of the contents of our file. Now, if you have a small file, then this is probably what you want. But what if we have an extremely large file that we want to read? but we don't want to load all of the contents of that file into memory. Well, there are a couple of other methods here that we have available for reading file contents instead of f.read. So just to look at a couple of those, I could say f.read lines, and if I print this out, then you can see that we get a list of all of the lines in the file. And it looks a little weird because we have our new line characters in there, but if we look through this list, then it actually gets every line of the file as a different element of that list. Now instead of f.read lines, I could do f.read line, and if I save that and run it, then you can see that read line grabbed the first line of our file. Now every time that we run f.readLine, it gets the next line in our file. So if I was to copy all of this and then do it again and run that, now you can see that it got the first and the second lines from the file. Now this printed out a little weird here because the print statement ends with a new line by default, but if I go up here and pass in an empty string to the end of our print statements, then it will no longer add in that extra new line, and now you can see that those are the way that they are in the file. Okay, but we still haven't solved our problem of how we can read all of the content from an extremely large file. If we f.readLine, it gets the next line in our file. So if I was to, I could do f. Read line, and if I save that and run it, then read line grabbed the first line of our file. Now every time that we run f.readLine, it gets the next line in our file. So if I was to copy all of this and then do it again and run that, now you can see that it got the first and the second lines from the file. Now this printed out a little weird here because the print statement ends with a new line by default, but if I go up here and pass in an empty string to the end of our print statements, then it will no longer add in that extra new line, and now you can see that those are the way that they are in the file. Okay, but we still haven't solved our problem of how we can read all of the content from an extremely large file. If we read the entire file in all at once, then we could run out of memory, and we don't want to go through and do f.readLine, thousands of times. So what we're going to do here is instead of using readLine or read lines, we can simply iterate over the lines in a file by saying for.
Still applying for jobs without tech skills? Let's fix that. Learn Python, SQL, Power BI, and more on DataCamp. It's
Let me go to a new line here. For line in F. And then from here, we can just print that line. So I'm going to copy that and save that. So now let me go ahead and comment out these lines and run this iteration over the lines. And you can see that it printed out all of the lines in our file. Now this is efficient because it's not reading in all of the contents from our file all at once. So it's not a memory issue that we have to worry about. What it's going to do is it's just going to go through and get one line at a time from the file. Now this is usually good enough for most people, but sometimes you may want more control over exactly what you're reading from the file. Now if we go back, I'm going to go ahead and delete this line. If we go back to our f.read line here, and I'm going to get rid of that one. Now I'm going to go back to using f.read, and if you remember, this read in the entire contents of the file. So if I run that, you can see that we got the exact same thing. But with f.read, we can actually specify the amount of data that we want to read at a time by passing in the size as an argument. So if I pass in a 100 to our read method and then print this out, you can see that it printed out the first 100 characters of our file instead of printing the whole thing all at once. Now, if I was to copy this and run this again, then you can see that it printed out the rest of the file because it picked up where it left off and read our file instead of printing the whole thing all at once. Now, if I was to copy this and run this again, then you can see that it printed out the rest of the file because it picked up where it left off and read 100 more characters of the file. Now, when we reach the end of the file, then read will just return an empty string. So if I was to copy this for a third time and rerun this, then you can see that nothing happens. Because what happens when we reach the end of the file, read just returns an empty string, so this print statement is just printing out an empty string. Okay, so how are we going to use this technique in order to read in a large file? So since we don't know exactly how long the file will be, we're going to have to use some kind of loop that just iterates over small chunks at a time. So instead of hard coding in 100 here, I'm going to create a variable here called size to read. And for now, we'll just go ahead and set that equal to 100. So now if instead of passing in 100 to f.read, let's just pass in this size to read. Okay, so this will grab the first 100 characters of our file. Now remember, when we hit the end of the file, then read will just return an empty string. So if we do a while loop and say while the length of f contents is greater than 0, then we will print out the contents that we got from read. Now don't run it like this yet because this will be an infinite loop. We're never advancing the contents of the file. After it prints the contents, then we want to read in the next chunk of characters. So in order to do that, then we just have to again say f contents equals f.read of that sized chunk. Now what it's going to do after this line here is that it's going to kick us back out to the while loop, and it will check if we've hit the end of the file because f.read will return an empty string and it won't meet this conditional. So now if I go ahead and run this, we again send the next chunk of characters. So in order to do that, then we just have to again say f contents equals f.read of that sized chunk. Now what it's going to do after this line here is that it's going to kick us back out to the while loop, and it will check if we've hit the end of the file because f.read will return an empty string and it won't meet this conditional. So now if I go ahead and run this, then you can see that it printed out all of the contents of our file. So to get a better idea of what's going on here, let's change the size to read to 10 characters instead of 100 characters. And every time that we print out f.contents here, instead of an empty string, let's make this an asterisk. So now if I print this out, then you can see it's a little bit more clear that we're looping through 10 characters at a time, and it's printing out these asterisks through every loop. So you can see that it came through the loop here and it printed out these, and then the asterisk that we know that it's just that chunk. Then it printed out the next 10 characters, and then the next 10 characters, and so on until we got to the end of the file. Now when we read from files, you can see that it advances its position every time. So we can actually see the current position using f.tell. So what I'm going to do is I'm going to comment out this while loop here, and down here I'm going to say print, and we'll print out f.tell. So if I go ahead and run that, you can see that f.tell returned 10. So it's saying that we're currently at the 10th position in the file, and that's because we've already read in 10 characters here, and we can manipulate our current position using the seek method. So to show an example of this, let me print the first 20 characters of the file by running f.read twice. So I'm going to go ahead and print out the contents after the first 10 characters there, and then I'm going to do this a second time to get the next 10 characters. And I'm going to go ahead and take out this second empty string there so that it pushes our finished statement out of the way. So now actually let me get rid of f.tell here and go ahead and run this. So we can see that it printed out the first 20 characters of our file. Now when we read in this second chunk here, it picked up at the 10th position and read in the next 10 characters like we would expect. But what if I wanted that second read to instead start back at the beginning of the file? And we can do this with f.seek. So between these two reads, if I was to do an f.seek of 0 and save that and ran it, now you can see that it set our position back to the beginning of the file. So the second time we read in our contents, it starts back at the beginning instead of picking up where we left off after the first read. Now we used seek 0 to start at the beginning of the file, but you can use it to change the position to any location that you'd like. Okay, so now let's take a look at writing to files, and a lot of this will be similar to reading. So first of all, what happens if we try to write from within a file that we have opened in read mode? So let's go ahead and try that. So I'll do an f.write, and I'll just do an f.write of test. I'm going to go ahead and get rid of that while loop also and save that. So you see when I have a file open in read mode and try to write, that we get an error that says that this is not writable. So we have to have the file open in write mode. So now back up here within our open statement, let's create a new file called test2.
Build an IoT app for your brand in 10 minutes. According to GSMA's forecast, the number of global IoT device connections is expected to reach almost
.txt. And instead of reading, we are going test file opened in. This will be similar to reading. So first of all, what happens if we try to write from within a file that we have opened in read mode? So let's go ahead and try that. So I'll do an f.write, and I'll just do an f.write of test. I'm going to go ahead and get rid of that while loop also and save that. So you see when I have a file open in read mode and try to write, that we get an error that says that this is not writable. So we have to have the file open in write mode. So now back up here within our open statement, let's create a new file called test2.txt. And instead of reading, we are going to write to it. Now, in order to do that, we can just say a lowercase w instead of that lowercase r. Now you can see over here in our directory that we don't have a test2.txt yet. Now if the file doesn't exist already, then this will go ahead and create it. Now if the file does exist, then it will overwrite it. So be careful if you're writing to a file that already exists. Now if you don't want to overwrite a file, then you can use a lowercase a for appending to the file. But we're going to go ahead and overwrite this file if it exists. So first of all, instead of writing to this file, I'm just going to go ahead and put in a pass statement here, which basically says don't do anything. So I'm going to go ahead and run this, and you can see that it created test2.txt. So I didn't actually have to write anything to the file in order to create it. Just using the open with the write mode will create the file. So now in order to write to this file, then we can just do what we did before. We can do an f.write test.txt. So I'm going to go ahead and run that. Now if we go over here to test2.txt, then you can see that it wrote test to our file. Now if I go back here and do another write to this file, then it's going to pick up where we left off just like the read method did. So now if I run this and go back to the file, then you can see that it wrote test twice back to back. Now you can actually use seek when writing files also to set the position back to the beginning of the file. And we can do this if I go back here between these two write statements and I was to do an f.seek of 0. Now if I run this, then you can see that the second test overwrote the first one. So seek can get a little confusing for file writes because it doesn't overwrite everything, only what it needs to overwrite. So for example, if instead of writing the same thing twice, if I was to do an f.seek at the beginning and write out an R as my second one there, and now if I run that and go back to the file, then you can see that the R only overwrote the T in test. It didn't delete the rest of the content. So using file seek whenever I'm writing to files, it can get a little confusing and I don't use it a whole lot, but maybe there are some use cases out there that you guys will find it useful for. Okay, so let's go ahead and pull all of this together and use read and write on multiple files at the same time. So we're going to use this to make a copy of our test.txt file. So let's go ahead and delete our test2.txt file here so that we don't confuse the two. And I'm going to go ahead and close that there.
Let us show you why UE is the place to be. UE's facilities help bring your idea.
Okay, so I'm going to go ahead and get rid of these here. So first, let's open our original test.txt file in a read mode. And instead of F here, I'm going to use RF. And I'll just say RF there for read file, since this is the file that we're going to read from in order to write to our copy. So now within this with statement here, I'm going to go ahead and let's go ahead and copy all of this and paste another open within here. And I'm going to call this a test_copy.txt. And I'm going to open this in write mode. And I'm going to call this WF for write file. Now you can actually put both of these open statements on a single line separated by a comma, but I think readability here is pretty important, and mixing those two on one line is sometimes difficult to understand, at least for me. So this is usually how I work with multiple files at a time, is putting them on two different lines, one nested within the other. Okay, so now within here we have two files open, RF for reading our original file and WF for writing to our copy. Now to do this, it's just as easy as saying for line in RF, we want to do a WF dot write of that line. Okay, so now let's walk over this one more time. So we have our original file opened and we're reading from that file, and we have a file that doesn't exist yet that's our copy, and we're writing to that file, and we're saying for each line in our original file, write that line to WF, which is the file that we are copying to. So if I go ahead and run that, then you can see that it created this testcopy.txt file. And if I open this, you can see that it is an exact copy of our original. Okay, and lastly, let's look at how we can do something similar and copy a large picture file. Now this is going to be slightly different. So if I look in my current directory that has my Python script that I'm currently running, I also have a picture of my dog here when he was a puppy. And let's go ahead and try to copy this picture file using file objects in Python. Now this file here is called bronx.jpg, and if I just try to replace our text files with these picture files, and down here I'll call this bronx underscore copy.jpg. Now this is exactly the same as our
Work is a pain in the apps.
Hey everybody, how's it going? My name's Hey everybody, how's it going? In this series of videos, we'll be learning how to create and use classes within Python and how object-oriented concepts are applied within the language. Now there's a lot to cover when working.
Hey there, how's it going everybody? In this video, we're going to be learning about the pathlib module and how to use it. Now this is used in place of the OS module for working with paths, and many people have been slow to move over to using this, but we're going to be learning about the advantages that it provides over using the OS module and why we should probably make that switch. Now we do have a sponsor for this video. Hey there, how's it going everybody? In this series of videos, we'll be going over the basics of Python programming. Now, I get a lot of messages from people who say that they enjoy my Python videos, but that they're either just getting started out in programming or coming from another language and would like a beginner's overview of Python so that they can better understand the more advanced topics. And that's what we're going to do here. We're going to cover how to get up and running with Python, how to work with the different data types, how to work with conditionals and loops and iterations, how to create functions, also importing modules and working with the standard library. So basically everything that you need to know in order to have a firm understanding of the Python fundamentals. Now, one thing I do want to point out is that throughout these tutorials, I'm going to go over a few topics that I've already made more detailed videos about, and anytime that happens, I'll touch on the basics of that topic, but then reference the more detailed video if you'd like to see more examples. And that will allow us to move along at a good pace. So let's go ahead and get started. So first we're going to learn how to install Python and set up our development environment. And we're going to look at how to do this on both Mac and Windows. And this is a pretty straightforward process. So first we'll look at how to do this on a Mac, but if you're on a Windows machine, then you can look in the description section below, and I'll put a link to the
In this video, we're going to learn how to create a directory in Python. The first thing we'll do is import the built-in OS module. This module contains a function